Welcome to Unit 5A, Quadratic Functions. Today we're going to be working on skill number 35. I can solve quadratic equations by completing the square and write quadratic equations in vertex form. Today's skill is broken into two parts, one being solve quadratic equations and the other is to write quadratic equations in vertex form. I believe it's easier to do the latter, starting with standard form to vertex form. So we'll start through an example. The example reads, please write f of x equals 9x squared plus 18x minus 3 in vertex form. This is a 5-step process, so let me walk you through the 5 steps. Step 1. Gather variable terms to one side. Place constant terms with the f of x. So our two variable terms were 9x squared and 18x, so we left those on one side of the equation, and then our constant term, negative 3, we added 3 to both sides, giving you f of x plus 3 on the left-hand side of the equation. Step 2 asks us to factor the x squared coefficient down to 1. And if you notice, currently our x squared coefficient is a 9. So if we factor a 9 out, we wind up getting 9 times the quantity of x squared plus 2x. I want you to notice that I left a large blank right there because part of completing the square will be filling that blank. Alright, step 3. Complete the square by adding b over 2 quantity squared. And we're going to add that to both sides. Our b value, as you can see right now, is a 2. So b over 2 is 2 divided by 2, and then we square that. 1 squared, 1. So we're going to be adding this 1 into that spot. You can see I've filled it out down below. Because I added 1, or 9 times 1, to the right-hand side of the equation, we need to add 9 times 1 to the left-hand side of the equation to maintain equality. Continuing our notes on page 5-17, we do step 4, simplify both sides and convert perfect square trinomial to squared binomial. So on the last page we had this equation, and what we want to do is simplify it. So the left-hand side simplifies very easily. 3 plus 9 times 1 is 12. And then the right-hand side relies on our ability to recall from the last skill, perfect square trinomials. And this perfect square trinomial becomes x plus 1 squared. If you've done everything right, the pattern that exists is this value, the plus 1, is equal to b over 2. So in our case, 2 divided by 2 is equal to 1. So we're able to put the 1 into that location. Step 5 asks us to write it in vertex form. This is pretty much moving the 12 from the left-hand side of the equation to the right-hand side of the equation. So we subtract 12 from both sides and we get the equation in vertex form. We have now moved from standard form to vertex form, and that's 1/2 of today's skill. If we wanted to, we could use this information to graph the equation. So negative 12 tells us that we are shifting down 12, and then plus 1 tells us that we're shifting to the left 1, and the 9 tells us we have a vertical stretch of 9. So over 1, up 9 times 1, over 1, up 9 times 3, over 1, up 9 times 5, over 1, up 9 times 7, etc. On page 5-18, I've presented a second example. Write f of x equals 3x squared minus 24x plus 9 in vertex form. So you can follow the steps. Step 1 was gather variable terms to one side and place constants on the other side. Step 2, factor the x squared coefficient down to 1. So the 3x squared became 3 times 1. Step 3 is complete the square. So what we did here, negative 8 divided by 2 squared is what's being added to both sides. So negative 8 was our b term, which is negative 4 squared, which is 16. So we add 16 to the right-hand side of the equation, and the left-hand side we're going to add 16 times 3 to maintain balance. Step 4, we simplified the left-hand side of the equation, and we also used a perfect square trinomial to simplify the right-hand side of the equation. Once again, notice that this negative 4 is the same as this negative 4. And then step 5, we wrote it in vertex form, so we subtracted 39 from both sides. As a quick review, this function is a shift down 39 units, to the right 4 units, and a vertical stretch by a factor of 3. We might be asked to find the zeros of a function in vertex form, or to solve a function. In this particular case, I just used the example from above, and I was solving for the zeros, which means f of x became equal to 0. So the first step I did was add 39 to both sides. The second step I did was I divided both sides by 3. Then I took the square root of both sides, and don't forget you need to include the plus and minus always. And then I added 4 to both sides, arriving at the 2 zeros of the function. The second part of this skill is solving quadratic equations by completing the square. A question might be phrased as such: solve 3x squared plus 12x equals 189 by completing the square. And this process is nearly identical to what we are just doing. The only difference is the f of x has disappeared. What we have is 189 equals 3x squared plus 12x. So in step 1 we gathered all the x terms to one side and all the constant terms to the other side. This is where the f of x was previously. In step 2, we factored the coefficient down to 1 by pulling a 3 out, and we get 3 times 1x squared and 3 times 4x. And we left our blank to be filled as per usual. Step 2, we completed the square, and that completing the square, 4 divided by 2 squared is equal to 4. So that's the number that we're going to add to both sides. And it adds right here, and because we added 3 times 4 to the right side, we need to add 3 times 4 to the left side. Step 4 was simplifying both sides. So 189 plus 3 times 4 is 201, and the right-hand side we used a perfect square trinomial. Step 5, we wrote it into vertex form. So our f of x, if we had it, would be located f of x plus 0. Now the only change that happens here is in step 6 we're solving for x. So we can add 201 to both sides. We can then divide both sides by 3. We can then square root both sides, and we get the plus and minus, and then we subtract 2 from both sides. It should be noted that we could have jumped straight from step 4 to this point of step 6. I simply included step 5 so that you could see the connection between the first part of this skill and this part. Alright, the next part of the video is actually just going to be a visual explanation of what we're doing when we're completing the square. You can take notes on it if you want to. You can skip over it if you want to, but I find it a very useful way to understand what exactly we're doing when we use this term completing the square. For a visual representation of this, let's take a look at this problem. X squared plus 4x equals 3, and we want to complete the square. So there's a couple different ways we can look at this visually, but I just wanted to share this so that you can see one possible way to understand what exactly completing the square is. We can factor x squared plus x plus 4 to be this. X times x plus 4 equals 3. Visually, what we have going on is a square that is x inches by x inches. And since we have x times x plus 4, really what we have is a rectangle that is x by x plus 4 inches. And the area of that rectangle is 3 cubic inches, we'll say. What we can do is we can actually take that rectangle and split it in half. So what we're having is a new rectangle that is x by x, and then the blue has been split in half so that we have an x by 2, and we'll do the other one that is x by 2 here. And this is all still equal to 3 square units. The term completing the square means what we're going to do is we're going to actually complete this square. We are adding this little square right here to our square. And what is the area of that? Well, the area of that is 4. So by adding 4 square units to this side, we have to add 4 units to this side. What this means is that we now have a rectangle that is x plus 2 by x plus 2. So our area of our rectangle is s plus 2, it's actually a square now, times x plus 2. And that is equal to 7 units. Or more cleanly, we can write this as x plus 2 squared is equal to 7. And if you remember, the whole point of this was to find a value for x to solve this equation. How are we going to solve this equation? Well, we used completing the square and created an equal equation that is probably, or actually is, easier to solve. And we solve that first by taking the square root of both sides. So now we have x plus 2 equals plus and minus square root of 7. And we finally arrive at x equals negative 2 plus or minus root 7. So we used completing the square to solve the equation that we would not have been able to solve using a factoring method. So the value x is negative 2 plus or minus root 7. I pulled this example from the website mathforteaching.com. You can see the web addresses listed up here. I would recommend checking out the website for a more complete explanation or more thorough explanation of the visual representation I just shared with you. Alright, this concludes the lesson on Algebra 2, skill number 35. For the skill test, what we're going to need to be able to do is take an equation that's in standard form and convert that equation to vertex form using completing the square. The other thing that we'll need to be able to do is solve a quadratic equation using completing the square. For example, 2x squared minus 18x equals 27. So we'd want to be able to solve that using completing the square. Bonus extra credits will be awarded to the first student in each period to deliver me the solution to this problem.